Hey guys, Mr. T here, just doing a video on the laws of logarithms. So when you're working with logarithms, there's a number of laws that apply that allow you to simplify complex expressions that have logarithms in them. In any base a, where a is greater than 0 but not equal to 1, so logs don't exist or are undefined when the base is 1 or less than 1, but anything greater than 1, logs work, okay? These following laws apply. Log in base a of m plus log in base a of n is going to be log in base a of the product of m and n, as long as m and n are greater than 0. The log in base a of m, take away the log in base a of n, is going to be equal to the log in base a of m divided by n. So you can see they're simplifying, shortening the expression. And then m times by the log in base a of b is going to be equal to log in base a of b to the power of m, as long as b is greater than 0. Now lastly, something to note here, at least as far as I know in Australia, please note that when you're working with logarithms, if no base is indicated, then you should assume that the base that we're talking about is 10. That's not really going to apply to a lot of the questions that we deal with, but that's just something to remember if you do some more extensive maths later in your life. So here's a couple of examples. Use the logarithm laws to simplify and write as a single logarithm or as a rational number. So a rational number being something that can be written as a fraction. Log 5 plus log 3, there's no base written, so I assume it's going to be base 10, but as I'm going to write the answer with no log either, it really doesn't apply here. I'm just going to apply the log laws. So log 5 plus log 3 is equivalent to log of 5 times by 3, which is going to be equal to log 15. That's an application of the first law. You see the same log base, adding, so you multiply the numbers of interest. Here you have a subtraction. Now, they're of the same base, so when it's a subtraction, you divide the numbers of interest. So it's going to be 24 over, not 3, over 8. 24 divided by 8, that is 3. So log, I forgot to write the base here. We're talking about base 3. That's important next. Log in base 3 of 24 divided by 8 is 3. And we can simplify this further. That is the answer, but that's not the easiest that we can do it because there's no unknowns here. And I know what number I have to multiply. I know the number of times I have to multiply the base of 3 by itself to get the number of interest of 3. It's 1. So that's obviously the most simplified we can get it. Next we have 2 log 7, take 3 log 2, no base written. Because we're just simplifying, it doesn't really apply. We're not trying to find the answer here. So this is an application of the bottom law. That m becomes a power of the number of interest there. So it's going to be log 7 squared, take log 2 to the power of 3. That's equivalent to log 49, take log 8. And then the second law that's written up there, when you have a minus with the same base, that's the same as the same base, and a division, 49 over 8. That's as simple as it can go. Now this last one here, we have log 8, log 4. I notice that they are both powers of 2. It's log 2 to the power of 3 over log 2 to the power of 2. That's equivalent to, so using this law, backwards, the power, if I go in reverse, the power goes out the front. So now it's going to be 3 log 2 over 2 log 2. We have the same thing here, log 2, so they cancel. Dividing something by itself is going to give you 1, so that cancels out. So it's going to be 3 on 2, rational number simplified. All right? So hopefully that helps you out, this video on the log laws and some examples. And I will see you in the next video.